with antiderivatives. If you think about the position function, and I'm going to call the position function S of t, you could call it X of t, P of t, whatever, but I'm going to call it S of t. If you remember, the derivative of position is velocity, correct? Well, that means I'm going to sit here and I'm going to take the antiderivative of both sides here. Now, what is the antiderivative of a derivative? It's the same thing as me saying, what is the square root of something squared? Yeah, it goes back. So the antiderivative of the derivative of S of t would just be S of t. So S of t is going to equal to the antiderivative of V of t dt. Likewise, the antiderivative of acceleration is the velocity. Now, we're going to look at something that deals with initial conditions. And just a little bit of a brief overview before we do the initial condition stuff. If I'm standing on top of a building or if I'm standing on the ground and I throw something up with the same initial velocity, whether I'm on the roof or on the ground, then at the same time it's going to have the same velocity. But its position is going to be different based on whether I was on the roof when I threw it up or whether I was on the ground when I threw it up. So that's what's going to fall into play here. I'm going to say that I know that my velocity is going to be 2t plus 7. And I want to know the position equation if S of 2 was 80. Now, I'm not giving any units here. I'm not saying that this is in terms of feet or meters or these are feet per. This is just a basic problem. My position when at 2 seconds